All right, so we've talked about slope-intercept form and all the ways we could use that slope-intercept form. Just as a quick review, is that y equals mx plus b, where m is your slope and b is your y-intercept. And we'll talk about intercepts a little bit more in just a second. We talked about how to graph using that form. We talked about how to write the equation of a line, a linear equation in that form, given some different information. But it's not the only form out there of a linear equation. Linear equations can be written in standard form, which is what we're going to talk about today. There's also point slope form that we're not going to get into a whole lot. It doesn't have a lot of uses, and so we won't talk about it too much here in this particular course. Okay, but we do want to talk about standard form, and there's some reasons why, and we'll get to those reasons in just a few minutes. So the point of today is to be able to write a function in standard form. You want to be able to graph horizontal and vertical lines, and we've done that already, so we'll quickly review that. And then we'll talk about x and y intercepts and how to use those to help us graph a line. Okay, the standards that we're going to hit. And so first things first, before we can use standard form, we have to know what standard form is. Again, I'll compare this to your slope-intercept form, right? Slope-intercept form means that it's a linear function where the y variable is by itself, and you can find the slope and the y-intercept from the ways that we've talked about before. Standard form is different in that the x and the y variables, still going to have an x and a y variable in the equation, are on one side of the equation together, where the constant of the equation is over on the other side by itself. So ax plus by equals c, and then where a, b, and c are real numbers, just any numbers, and we have to understand that a and b cannot both be 0. If a and b are both 0 at the same time, then our equation basically boils down to 0 equals c, and that may or may not be true. So now a can be 0, b can be 0, but they can't be 0 at the same time. Okay? So anyway, there's your standard form. Only considered standard form if x and y are on one side of the equation together. All right? Now, it's been a little while, so let's do some quick review first. I want to review slope-intercept form, so let's work on getting these next few equations in slope-intercept form and then graph. Don't worry about the domain and range down here. Okay? Now you have to remember, slope-intercept form means we're going to get the y variable by itself. So to do that here, and we'll do this one together, subtract 2x from both sides. Right? And that gives us 3y on the left-hand side. We cannot combine negative 2x and 6, so just bring them down. Okay? And then we're going to divide everything through by 3. Okay? So we get y equals negative 2/3 x plus 2. Okay? Now graph. Remember, this is your y-intercept. Y-intercept is where the line touches the y-axis. So that means we're going to start right here. This is the y-axis. This is the x-axis. And then the slope tells us where to walk for the next point. So we want to go down to, since it's negative 2/3, down to right 3, and that puts us here. We can go down 2 and right 3 again. That puts us right here. Okay. As a matter of fact, the slope being negative 2/3 is going to be true for the entire line. A line has a constant rate of change. That's what a slope is, right? It's rate of change. How much this variable changes as this variable changes. All right, so anyway, some more review about slope. So now we can just graph our line here. Okay? All right. So there's your memory jog. So try it on your own here for the next one. Negative 2y plus 5x equals 10. You can stop the video, work it out, and then start it again, and I'll show you what you should have gotten. Okay? All right, so this is what you should have done, right? Subtract 5x from both sides. and then divide everything by negative 2. And so you end up with 5 halves x minus 5. Okay? All right, so again, y-intercept is negative 5, so you're going to start down here. And the slope is 5 over 2, so we're going to go up 5, right 2. And then up 5, right 2. Now, remember, you can always go down 5, left 2. If your slope is positive, you can always go in 2 negative directions, since 2 negatives make a positive. Anyway, there's your line. Okay? All right, got one more for you. So try that guy. And the hint that I'll give you here is that you want to clear those fractions. So you got to remember how to clear those fractions. Let's give it a shot. And then start the video again to see what you should have done. Okay? So clear fractions, what do we mean? We mean multiply through by the least common denominator. And the least common denominator for all these denominators is going to be 6. So we're going to multiply this by 6, and this by 6. So we get 6 times 7 is 42, divided by 3 is 14. 6 times 7 is 42, divided by 2 is 21. And 6 times 7 is 42, nothing to divide into there. Now we're back to our regular method of trying to get y by itself. So subtract 14x from both sides. Okay? And so y is equal to negative 2/3 x plus 2. Okay? All right, so graph, y-intercept is 2. Negative 2/3 is the slope, so go down 2, right 3. Down 2, right 3. And we're ready to draw our line. Okay? So something like that. All right? All right. Now, some quick review of horizontal and vertical lines, and I'm going to reintroduce Vux and Hoy again. I kind of like that. I think that's a pretty good method of remembering what the details are on vertical and horizontal lines. First things first, a horizontal line. Hoy. Horizontal line goes with Hoy because there's an H in Hoy. Okay? And I'll show you how to use Hoy. I've done it a bunch of times. I'll keep doing it. But a horizontal line, there's your H. Oops. There's your H. Has a 0 slope. There's your O. Has a 0 slope. And you know what a horizontal line looks like. It's not going to cross the x-axis, right? These horizontal lines down here, the blue and the red one here, they do not cross the x-axis. So what we do is we drop the x variable from our linear equation, and all we have left is the y variable. So the equation looks like y equals, and it's equal to whatever number the line hits on the y-axis, right? That's why there's a y in Hoy, because the equation of your line is just going to be y equals some number. Okay? So for example, this horizontal line right here has a 0 slope, and the equation is going to be y equals 4, because it hits 4 on the y-axis. Down here has a 0 slope, the equation is going to be y equals negative 2. Okay? So anytime you see a linear equation with just a y in it, you know it's going to be a horizontal line. And that's how you're going to graph it. Okay? So that's your horizontal line. Your vertical line. Okay? Vux goes with your vertical lines. Okay? Have an undefined slope. So V is vertical, U stands for undefined slope. Now, if we were to ask you for the slope of a vertical line, you cannot write down 0. It's not a 0 slope. It is an undefined slope. So if we were to ask you to write the slope of a vertical line, you would have to write down undefined. Okay, so make sure you understand the difference there. Again, you know what vertical lines look like. Vertical lines are not going to hit the y-axis. Okay, remember this is the y and this is the x. So a vertical line is not going to hit the y-axis. So for that reason, we drop the y from the equation. and all we're left with is x. So the reason why there's an x in Vux is because the equation of the line is just going to look like x equals whatever number the vertical line hits the x-axis at. For example, vertical line, slope is undefined, and so the equation is going to be x equals -3 for this guy. And the same thing for here. Vertical line, slope is undefined, and so the equation is going to be x equals 2. Okay? So let's try some. Should be quick and easy. Again, we're not going to worry about domain and range. Y equals 4. Is that going to be a vertical or a horizontal line? Well, hoi, right? Since there's a y in here, hoi says it's going to be a horizontal line. Slope is going to be 0. It should look like this, a horizontal line going through 4 on the y-axis. That's it. Piece of cake, right? How about here? Okay, how about here? So x, we see an x in there, so it's a situation where we're going to use Vux. So it's going to be a vertical line. The slope is going to be undefined. Where does it go? It's a vertical line, and it's going to go through and hit the x-axis at -3. Because we have to get the x by itself. So subtract 3 from both sides. And x is -3. Okay? So just make sure that the x and the y and these guys are by themselves before you try to graph it. All right, another quick one here. Y. Y is a situation where we're going to use hoi. So it's going to be a horizontal line. The slope is going to be 0. And so your graph is going to go right through -3 on the y-axis. Okay? All right, good. Now, let's get into our standard form and how we're going to use that. And to do that, we have to understand what an x and a y-intercept is. And we keep talking about it with the slope-intercept form, what a y-intercept is. And it's simply, intercept means it's where the graph intercepts the axes. It's the way to remember this. So a y-intercept is where the graph crosses the y-axis. And the x-intercept is where the graph crosses the x-axis. Okay? Now, there's a way to figure out the x and the y-intercepts. We can't get the x-intercept from slope-intercept form. We can get the y-intercept, but not the x. Okay? But there is a way to get the x-intercept if we're in standard form. Okay? And we use something called the cover-up method. And I'm going to show you what that is. That's going to be the quick way to find the x and the y-intercepts. I want to talk to you a little bit about why, though. Okay? Now, before I get there, why do we care about the x and the y-intercepts? Because while we're asking you to plot 3 points to graph your lines, you really only need 2. 2 points make a line. So if we know where the graph is going to touch the y-axis and we know where the graph is going to touch the x-axis, that's 2 points. We can draw our line with those. Okay? So let's talk a little bit about what the cover-up method means. And in order to do that, we have to know some coordinates, right? Here's the y-intercept. It's where this graph touches the y-axis. What are the coordinates for that point? Well, hopefully you know that the coordinates are 0, 2. As a matter of fact, if this graph were to touch here on the y-axis, or here, all of these points would have the exact same x-coordinate. And that x-coordinate is 0 for all of those guys. So a y-intercept is always going to have the coordinates of 0, y, wherever it touches the y-axis. In other words, the x is always going to be equal to 0. Okay? We have to remember that. Now, compare and contrast that with our x-intercept. So our x-intercept is right here. The coordinates for that x-intercept are -3, 0. And as a matter of fact, if the graph were to hit here or here or here, all these points would have that one thing in common, which is all of the y coordinates would be 0. Okay? In other words, all x-intercepts have a y coordinate of 0. The x coordinate is going to be whatever number we are on the x-axis. So in other words, y is always going to be equal to 0 if it's an x-intercept, if we're trying to find an x-intercept. Now that's going to be true no matter what type of function we're talking about, whether it's a linear function or a quadratic function or a cubic function or a root function or an exponential function or a trig function. Now all these other functions you're going to learn about later. But anytime you have a function and you want to graph it, you can always find the x and the y intercepts this way. If the function's going to hit the x or y axis, if you use the information that I just gave you, where if it's a y-intercept, the x is always going to be 0, and if it's an x-intercept, the y is always going to be 0, then you can find those intercepts fairly easily. Okay? Now, how does that relate to the cover-up method? And I'm going to show you that in this next example. Okay? All right. Graph this. And we're going to graph this using not trying to get y by itself and using the slope-intercept form. Instead, we're going to try to use the x and the y intercepts. So I want to find where it touches the x-axis, and I want to find where it touches the y-axis. So I want the x and the y intercepts. Okay? Well, if it's an x-intercept, what did we just say? If it's an x-intercept, the y is always going to be 0. So what we can do is we can plug in 0 for y. If we do, then we get 5 times 0, which is just 0. And then we get 2x plus 0, which is just 2x. So if I were to plug in 0 for y, the equation would simplify down to 2x equals 10. Divide both sides by 2, and x equals 5. So now I know that this graph is going to hit at 5 on the x-axis, right here. I've got 1 point. Y-intercept. Remember that for a y-intercept, the x is always 0. So now I can plug in 0 for x. 2 times 0 is 0. 0 plus 5y is 5y. And so if I'm looking for the y-intercept, I can just simplify this equation down to 5y equals 10. Divide both sides by 5, and y equals 2. So now I know that the graph's going to hit 2 on the y-axis. Now I've got my 2 points. I'm going to graph my line. So the y-intercept is going to be 0, 2, and the x-intercept is going to be 5, 0. Okay? And that's it. Now, how does this relate to the cover-up method? What in the world is the cover-up method? Okay? Well, the cover-up method, basically we cover up part of the equation. If I want to find the x-intercept, then I'm going to cover up the y term. And if I do that, all I'm left with is 2x equals 10, which is what we wrote down here. And vice versa. If I'm going to find the y-intercept, I'm going to cover up the x term, and we're left with 5y equals 10. So when we're covering these terms up, I want you to remember, and I want you to understand that if I cover up the x term, that just tells us that x is 0, and it just is going to go away anyway. Okay? But that's the cover-up method. We're just going to cover up part of the equation. Now that's a lot of why the cover-up method works the way that it works. Okay? Now let's talk about just using it. For this next guy, if I want to find the x-intercept, if I'm going to find the x-intercept, I'm going to cover up the y part. And so I'm left with the equation that looks like -3x equals 18. Divide both sides by -3, and x is -6. And so my x-intercept is going to be -6, 0. Okay? So I can go over here to -6, 0 and place a point. Now, if I'm going to find the y-intercept, then now I'm going to cover up the x term. And I'm left with 6y equals 18. divide both sides by 6, and y equals 3. So my y-intercept is going to be 0, 3. So here, I've got my 2 points. Now I can graph my line. And so it's pretty much that easy with the cover-up method. Okay? All right, you've got one to try here. Stop the video, give it a shot, see what you come up with, and I'll show you what you should have. Okay? So what did you come up with? X-intercept. Okay? Now, this equation is not in standard form. But we can still use this cover-up method. It's just going to be a little bit different. You have to understand what's going on when you cover up. So if I'm going to find the x-intercept, I'm going to cover up the y term. And so I'm left with negative 4x equals negative 20. Divide both sides by negative 4 and you get 5. And so your x-intercept is going to be at 5, 0. So here. Now, to find the y-intercept, this is where it gets a little bit weird to see. But to find the y-intercept, we cover up the x term. Now, if I cover up the x term, there's nothing on the left side of the equation. Since there's nothing on the left side of the equation, we just make the left side of the equation 0. Remember I said the reason why we're covering up the x term is because we're making x 0. 0 times negative 4 is 0, so the whole left side is just 0. And we get 5y minus 20. So now we add 20 to both sides, divide by 5, and so y is 4, and so our y-intercept is going to be at 0, 4. Okay, which is right here. We graph the line. A little bit better than that probably, but it's a rough sketch, so close enough. Okay? So there you go. One more here for you. Graph using x and y intercepts. There's a curveball here. See if you can pick it up. Okay, so how'd you do? Did you understand that since it's y equals, y is the only variable you see, this is actually going to be a Hoy situation. So it's going to be a horizontal line where the slope is 0, and it's going to go through 2. Now, using the x and y intercepts. Well, for the x-intercept, well, it's a horizontal line. There are not any x-intercepts. So you can't use them. The y-intercept is where you're supposed to cover up the x, but there is no x. So you just get y equals 2. So it's going to touch the y-axis at 2. And so your y-intercept is 0, 2. Okay, so it's a little weird using the x and y intercepts. If you remember Vux and Hoy, it doesn't matter, just graph using that. Okay? All right, so a little bit of a curveball there. All right. Now, standard form. When are we going to use standard form? When we see this in this type of situation. So in a pickup game of basketball, baskets are worth either 2 or 3 points. If Miss Hall scored 24 points, write and graph an equation that represents the numbers of 2s and 3s she hit in the game. And then list 3 possible combinations of 2s and 3s. How can there be 3 possible combinations? Well, think about it. Could she have hit all 2s and got 24? Sure. Could she have hit all 3s and got 24? Absolutely. So there's 2 possible combinations right there. And there are others. And being able to write the equation and graph it, the graph will show us all the possible combinations, right? All right, so first things first, we've got to be able to write the equation of this situation. So let's start with a generic representation first. In other words, Miss Hull had a total score, right? Where does that total score come from? Well, it comes from the points that she hit from 2s plus the points that she got from the 3s. How do we figure that out? Do we know how many 2s she hit? No, we don't. So how about we let x be the number of 2s that she hit? Do we know how many threes she hit? No, we don't. So how about we let y be the number of threes that she hit? Okay. Well, how do you find out how many points she got from twos? Well, we have to take the number of twos that she hit and then multiply it by 2. So it would be 2x. And then how do we figure out how many points she got from threes? Well, we'd have to take the number of threes that she hit and multiply it by 3. And that will help us get her total score, which we know is 24. So there's your equation. Okay? Now, here's the y-axis, here's the x-axis, and we've blocked off the negative side of the x-axis and the negative side of the y-axis because we don't need them. You can't hit negative number of 2's and a negative number of 3's. Okay? Now, we can label these axes too. This is going to be the number of 2's hit, and this is going to be the number of 3's hit. Just to help us remember. Okay? Well, let's graph this. And we can use the cover-up method. Find the x-intercept. To find the x-intercept, you're going to cover up the y, and you're left with 2x equals 24. Divide both sides by 2, and x equals 12. Now find the y-intercept. Okay, this is where we, instead of covering up the y, you cover up the x. And so you get 3y equals 24. Divide by 3, and y equals 8. Okay? So you go graph those intercepts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're right here. And 1, 2, 3, 4, 5, 6, 7, 8, and right here. Okay? And here, you're going to want to draw a very straight line. So you need to find something, a ruler, the edge of something, a notebook, or your calculator cover, or whatever. But we want to draw as straight a line as possible. Because like I said, the graph will show us the number of combinations, or not the number, the combinations of 2's and 3's that she could have hit. Okay? And here's what I mean. The coordinates for this y-intercept is 0, 8. Which means that x is 0, y is 8. And that would satisfy this line, that would satisfy this equation. And so therefore, that would tell us that she hit 0 2's and 8 3's. Down here, this point is on the line, so this point will satisfy the equation. This point is 12, 0, which means that x is 12, y is 0, so that means that she would have hit 12 2's and 0 3's. But there are all kinds of other points on this line. Here, 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 here. All these points are possible combinations of x and y's. Okay? Now, the only ones that make sense are the ones that are going to give us whole numbers. And so we need to find where this line hits nice, pretty numbers, which are going to be the corners of these boxes. So like right there. That point, the coordinates are 3, 6, which tells us that she hit 3 2's and 6 3's. Okay? Another nice, pretty point is right there, which means that she hit, so the point there is 6, 4, which means that she hit 6 2's and 4 3's. So all you need to do is find 3 possible combinations, and I've listed 4 already. So you just need to find 3 and use 3 of them. Okay? But that's what the line is telling us. It's showing us all the possible combinations of 2's and 3's. Okay? All right. So now you try. Mrs. Coyne decided to buy Chick-fil-A for her star class. She took orders for chicken sandwiches that cost $2 and chicken nuggets that cost $3. She spent $48 on the entire order. So write an equation first, and then find 3 possible combinations of the number of chicken nuggets and chicken sandwiches she bought. Stop the video, give it a couple of seconds, and see if you can't figure out how to write the equation, define your variables, and then graph the equation and figure out the number of possible combinations there were. Okay, did you get this? Okay, now, if you chose to use x and y, which I think makes more sense, you can make this x and this y, which means that this is going to be x and this is going to be y, and we're going to change a lot of these variables. Okay, and that's no problem. We can do that. Okay, so you let x be the number of nuggets, y be the number of sandwiches, and so you have to try to figure out how she got to her total cost of $48. Well, $48, that means that you take the number of nuggets ordered and multiply it by 2. Actually, these are reversed, aren't they? So x should be the number of sandwiches, and y should be the number of nuggets. Okay, she got them. These are backwards. Okay, that's all right. So let's see. I wonder if it's better off if instead of changing all this around, we just change our x and y around. Okay, that's going to be easier here. So, sorry, let's back up. This is what you get for using someone else's notes. Okay, let's see. It's still not going to make a lot of sense. All right, so let's do this. Let's back up. So I'm going to let x be the number of sandwiches and y be the number of nuggets. Okay, so how do we get to our total cost of $48? Okay, well, the sandwiches are $2, so I take the number of sandwiches, x, and multiply it by 2 to find the total cost from sandwiches. And the cost from nuggets, I'm going to take the number of nuggets that are ordered and multiply it by the $3. Okay, now, that means that here's our x-axis, here's our y, so x is sandwiches, and y are nuggets. That's going to get us in trouble, I'm sure. Okay, now let's find our intercepts. Cover up y and you get 2x equals 48. And to find our y-intercept, cover up x and you get 3y equals 48. Divide by 2, x is 24. Divide by 3 over here, and you get 16. Okay, so we need to plot those. 24 on the x-axis and 16 on the y. Now that's hard. We don't have enough tick marks, but if we make each tick mark worth 2, then we have enough room. So that's going to be 8 there, 12 there, 14, 16, 18. That's not going to give us enough room either, is it? So we need to rescale this again. And make each of these, let's make them 4. So this is going to be 8, 12, 16, 20, 24, 28, 32, okay? Oh, wait. Weird. 16, 18, so 20, 22, 24. 28, 32, and so on and so forth. Now the nuggets, the y's, need to go up to 16. So we should be able to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, so on and so forth. So we've got to put a point here and a point here. And now draw your line. Okay? And again, this is going to show you the number of combinations. So you could go 0, 16 or 24, 0 to get to your possible combinations. Those are 2 points on the line. You can also go here, which is going to be at 8, 12. Pay attention to your scaling. And so it could be 8 sandwiches and 12 nuggets. 0 sandwiches, 16 nuggets. 24 sandwiches, 0 nuggets. Find another nice, pretty point, right? This is going to be 18, 6. It'll be 18 sandwiches and 6 nuggets. Now, any of these points that you choose, you're going to want to plug back into the equation to make sure that it works. So you plug in 8 for x and 12 for y. 8 times 2 is 16. 3 times 12 is 36. And that would need to work. Okay. And I don't think it does it? So we messed up somewhere. All right, so I had my x-axis scaled incorrectly. Now it's fixed. Now we should be okay. But our possible combinations are going to change a little bit here. So we have one here, which is at 8, 10. So if we plug that in, actually that's not a nice pretty point either, and it's kind of hard to tell. There's one here, okay, and what you could do is actually take an x value, plug it in, and then solve for y, okay? But hopefully the nice pretty points are going to just jump out at you. This one is one, which is at 12, 8, and that would work. Now, what I mean by that is you could take an x value like 12 and come up here and plug it in, okay? So you could go 2 times 12 plus 3y equals 48. And you get 24 plus 3y equals 48. Subtract 24, 3y equals 24, and then so y has to equal 8. And that will tell you what your points are, 12, 8. Okay? But anyway, that's going to be another possible combination. Okay? All right. A little bit of a mess in this last one, but we've got it figured out, and we got it straightened out now. So that's it. That's it for standard form. You've got some homework out in Canvas. Make sure you get that done.